So as we've seen, during the simulation, we can use the Vellum constraint properties node to change the properties of a constraint, the rest length, for example. And we've used that to pump up an object with a rest length of a pressure constraint. Now what we want to do now is we want to stick an object to another, which is not actually the change of a property of a constraint, but a constraint itself. Because what you can do is actually generate connections or constraints during the simulation that weren't there in the beginning of the simulation. To demonstrate that, I have a simple example here, a sphere, and we want to kind of throw it into this piece of cloth. And currently it's set up in a way that both have their own Vellum constraints. And if I press start, they just both fall down because we haven't done more to it. The only thing I have prepared is a pin group. So to pin the upper part of my cloth here, I could have also used in the planar patch the top seam to do the same, but this one gives me a little bit more flexibility later on. And I use this, of course, in the patch cloth constraint under the pin to animation, and I just choose my pin group that I just created, and then the ball will still fall down, but at least the cloth is hanging in the air. Great. So the next thing we can do is, as we know, we can give this sphere, or actually more specifically every point of this sphere, a start velocity. And for this I use a point wrangle as usual, and all I set is the v attribute, and I set it to a vector. And in this case, when I look at the direction, which you can't see because my head is in the way, this is actually z, and the direction is negative z. So I need something like 0, 0, and I don't know, maybe -5. I'm not sure yet. Let's see. If I press start, yeah, that's actually pretty good. Okay, so we have now the base set up, and as you can see, nothing sticks. So the first thing we could try is create a constraint that glues the two together, and maybe from the outside it will, be recognized during the simulation. So let's quickly try this. We could try a stitch points or a Vellum glue constraint. I take the glue constraint, it's easier for the setup like this, but theoretically a stitch constraint would work as well. And let's see, as you can see, there's no connection, otherwise we would see it. We can kind of make it by increasing the search distance quite a lot to maybe this, and nothing is happening. Why not? There you go, because we need more search points, and then the connection is done. But that's of course not what we want, right? Because if I run this now, then you can see the sphere weirdly hangs on the cloth, which is kind of weird and looks like this and is not really what we want. So what we want, of course, is when it gets closer, then the connection only should be done. So of course what I will do is I can keep the max search points, but I can lower the max search distance to the default back to 0.1 and see what happens if I run this now. And as you might guess, it's not working, because it's important for you to understand you cannot create a constraint and expect it to change its behavior during the simulation. So we can't do this from outside, but this is why we have our dive target again, and actually here is described as via Vellum constraints to build new constraints. And here is actually the node they're referring to, the Vellum constraints node. Now, as we already figured out, we need a glue constraint. Stitch points constraint would have worked as well. And we keep the max search distance at 0.1, and the max search points with 10 will work. I will increase this higher nonetheless, just to be safe. And let's see what happens if I press start. Now, unfortunately, nothing happened. Why? What's going on? Let's see if we have any kind of connection that is created when it gets closer. And no, there's none. And the reason is, and this is really kind of stupid in my opinion, the Vellum constraint node by default has a really bad setting, and that is up here under create constraints. It is set to on creation frame. In other words, even though it's described here to use this node, it is set in a way that it behaves the same as if you would have created it outside, because it only calculates on the creation frame. Pretty stupid default. I don't get it, to be honest, because the whole point of this node is to do it dynamically during the simulation. But anyway, so let's change this from on creation frame to each frame. And now whatever is set here will happen every frame. So let's rewind and run this. And there you go, now it's sticky, because what's happening is that the connections, as soon as the distance got close enough, will be created because it is calculated every frame. Let's visualize this by making sure that we create a group, and it's already there under output group. It's called Vellum constraints 1 stretch. Well, let's actually call this node glue then, because then the naming here will be adjusted. Of course, you can overwrite this as well, but I just want to make sure that I will find this again. Because what I want to do now is I want to delete everything in the constraints except the, and let's actually calculate at least 1 frame. Oh, it's not there yet. Okay, so let's let's run this. So to a point where the connection is actually happening. So, and now I should be able to find this. There it is, glue stretch. And I want to delete everything that is not glue stretch. So my point here is that I want to see the connections when they are created, and now they are created. There you go. So as you can see, you can create constraints dynamically, and this is one way of using it. So we could finish here. Pretty good to know that we can do that. Just be careful. You use the Vellum constraints node, but if you want it to be dynamic, make sure you change the create constraints from on creation frame to each frame. Otherwise, there's no point. And what we can also do is everything we learned so far. So a nice little effect here is that once the connection is done, let's make sure that we can actually break it again. And for this, I've prepared a similar example, and that is I just took a box instead of a piece of cloth. And it's important that it has enough resolution, because the connection with the glue constraint is between points, not surfaces, other than the stitch points. And then I took another group for everything, which is a point group, and put this into the pin points selection, because this way now my whole box is basically static and doesn't simulate anymore, and then it looks like this, which is a nice way of creating, you know, an active but still static object in a way. So as you can see now, the funny thing is it sticks to it, and because it's harder, it behaves a little bit different. Now what I want is this slime ball to kind of roll down, and this is something I can do by activating the breaking threshold, because I can also make sure that this connection here is breaking based on the stretch stress. So let's see if that works. But let's first turn our sphere green, because it's much more fun. Okay, so that was very important. And now I press start, and you can see right now nothing happens because the threshold for the stretch stress is not high enough. So let's lower this further. And let's lower this to a pretty low number, so it should definitely break. But as you can see, it still doesn't break. And the reason here is that when you look at the connection, that one connection breaks, but another one is created again. And this is quite normal, but you can see it kind of works. It breaks and then it finds new connections. And in case your blob doesn't want to move, even though you have maybe set a very low breaking threshold, I noticed that playing with the other settings, like how easy a connection can be made, can help here. So for example, if you lower the max search distance so that only the really closest points get connected, this can help you with this effect. So I'm lowering the max search distance to 0.002, and then the connections, there are fewer connections basically. Now it's too few. So let's go back to 0.003 maybe. Yeah, something like that. And now you can see what I wanted to show you. You have this wandering blob that kind of finds connection and breaks connections again. And there you go. And if you find the right balance of the settings, you can actually get this funny slimy effect. Okay, so this is about dynamic constraints and what you can do with it. Try to find a funny use case for this. So I hope this is helpful. Thanks very much and see you later. Cheers.